Nuclear Bomb Scaling by Johnny Vincent and Stefano. The gradual buildup of powers of nuclear weapons. Starting with the creation of the first nuclear weapon at the tail end of the Second World War, the technology has increased the destructive power 3,333-fold in under 3 decades. The result was an arms race with the Soviet Union. This was due to fear of spreading each other's forms of government along the nuclear threat. Purpose of development. Positives. Deters major global conflicts. Negotiation becomes first weapon of choice, rather than a nuclear war. Increase in the nation's power/status. Provides foundations to each other's technologies, nuclear power, introducing new sources of energy. Nuclear weapons provide sustenance to smaller nations' voices on the global scale. Purpose of development. Downsides. Weaponizing leads to destruction in time. Increased mining of uranium leads to heavy pollutants and mining issues. Nuclear waste contamination issues, mass death after nuclear fallout or nuclear device activation, and increased chance of weapon proliferation. Associated scientific advancements. Direct. Nuclear energy, particle acceleration. Indirect. Aerospace innovations, rockets, missiles, satellites. Science behind. There are 2 general types of nuclear weapons, fission and fusion. The first generation nuclear weapons are fission weapons. Fission weapons are relatively simple and only rely on splitting of a radioactive element, often uranium-235, as nuclear fuel. The first nuclear weapon developed was the gun-type device, where an explosive propelled 2 subcritical masses of radioactive material into each other, creating a supercritical mass and a subsequent mass decay of particles. The first test was July 16, 1945, dubbed Trinity, in Alamogordo, New Mexico, yielding 22 kilotons of TNT equivalent. The largest was on November 16, 1952, dubbed the Ivy King, on Eniwetok Atoll, and it was 500 kilotons. Science behind the fusion type. Fusion weapons are based on the joining of elements to release their destructive energy. As second-generation atomic weapons, they are considerably smaller than their first-generation counterparts and are also drastically more complicated. The most common form of fusion bomb is a hydrogen bomb or H-bomb, as it employs deuterium and tritium, isotopes of hydrogen, as its nuclear fuel. The first test was on November 1, 1952, in Ivy Mike on the Eniwetok Atoll. The largest ever nuclear bomb test, in fact, was on the 30th of October, 1961, dubbed the Tsar Bomba, on Severny Island in the USSR, and it had a 50 megaton equivalent yield. In conclusion, nuclear development after the Cold War has given society the ability to advance in power, nuclear energy, and national defense. Development has forced nations into negotiations and brought an alternative energy source. Conclusion. Questions. What are 3 benefits of nuclear advancements after World War II? And which generation of nuclear weapons are considered smaller yield? There are the answers. And here are our references.